Hey everyone, Mr. Sharkey back with another exciting chemistry video. Today we're going to be looking at Unit 1, Worksheet 3, questions 1 through 3. We're really just going to go over question 1 together, and that's going to set up the basis for the rest of these questions. So hopefully watching this video, seeing my process for question 1 will be enough to help you guys figure out questions 2 and 3. So what we're doing here is we're looking at a particle diagram. In this case, we're looking at box A and box B. And we're trying to decide which one has more mass, volume, and then density, or if those are equal to each other. So starting off with mass, I want you to take a second and actually try to figure out which of these two boxes has more mass. So if you need to pause the video, go ahead and do so. But hopefully, after you've looked at it and thought about it for a second, you realize that B has more mass than A, or you could say that A is less than B. And if we think about the reasoning, hopefully the thing that stuck out to you was the number of particles. Because remember, whenever we talk about mass in a particle diagram, the first thing we're going to discuss is the number of particles. So what I could say here is that B has more particles than A, which means it has more mass. All right, I want you to do the same thing for volume. Look at the two, see if you can figure out which one has more or if they're equal, and then try to write out some reasonings. All right, hopefully you've had a chance. Looking at these two boxes, hopefully we realize that B has more volume than A, or we could say that A is less than B. In order to describe this, there's a couple of things that students commonly go to. But remember our definition for volume. Volume is the amount of space that an object takes up. So in our reasoning, we need to reference that definition again. So we could say that B takes up more space than A, which means B has a greater volume. Final question is about density. Now remember, density is always mass divided by volume. Or if we think about this ratio as a for every statement, we could say it's the amount of mass for every one volume. So think about what that means for a second. Try to compare the density between these two pictures, and then see if you can come up with a reasoning for your answer. Again, pause the video if you need to, and then come back once you've actually tried it on your own. Trying it on your own is always better than just watching me do it in a video. Now that you've had a second, hopefully you look at this and you see that A and B actually have equal densities. And this one is kind of the trickiest for students to understand. There's a couple ways we could go about it. One of kind of the shortcut answers here would be to say that there's an equal distance between particles. So I'm going to zoom in on A and B. If we look at these particles, we could say that there's an equal amount of space between the two. And that's one of the things that students go to when they try to recognize density, looking at space between particles. However, one of the other options that we have is trying to divide our box or our image up into equally sized volumes. So what I mean by that is I'm just going to draw a square that's roughly the same size. Since I'm working on my iPad, I can actually make sure it's the exact same size. But I'm going to start with this box here. And if I look at this box, there's pretty much 4 particles inside. But then what I can do with the magic of my iPad is I can copy this box, and then I can place a new box in the other diagram. And what we'll see is that, again, there's exactly these 4, or kind of like 3 and 3/4 particles inside the box. So there's 2 different ways that we could actually describe density here. And let's walk through those together. The best explanation would be to say that A and B have equal masses in a given area, or we could say that the ratio of mass to volume is equal. Or the last way that we could describe it here, we could say that the particles in A and B are spread out the same amount. We don't want to say that the particles are compact, because compact is sort of a vague term here. That could mean that the particles themselves are small, or it could mean that all the particles have been pushed together. So if you take this last approach that I'm going to put in brackets, you have to talk about the distance between particles. So here we're saying they're spread out the same amount. That is talking about particles in relation to each other. But I think this is kind of the trickiest way to describe density, because if you're not careful with your words, you can get something wrong. I think those first 2, talking about mass in a given area or ratios of mass to volume, I think those are going to be more clear and therefore easier reasonings for us to write. So there's question 1. I want you guys to see if you can try questions 2 and 3 and see what changes around. Check in with groups around you if you're unsure. But a lot of today, you guys are going to have to work together. And if you end up with questions, you're going to have to ask me those questions next time we see each other. So good luck, and I'll see you all soon. Thanks.